Have you ever wondered how many atoms there could be in the entire universe? It's a number so unimaginably large that it will leave your mind in awe and completely overwhelm your imagination. The sheer quantity of atoms is so vast that it defies any measure and shows us the immensity of the universe in a way that humbles us. Yet even this incomprehensible number is just the beginning, because the true infinity of the cosmos extends far beyond what we can grasp with our limited understanding. In this video, let's take a step back and take a closer look at the observable universe, that part of the cosmos that we can perceive and study with our most advanced telescopes and instruments. Countless galaxies, nebulae, and stars stretch across billions of light years, forming a cosmic network of unimaginable beauty and complexity. But no matter how far we look, no matter how deeply we delve into the secrets of the universe, we always see only a tiny fraction of the whole. It is a humbling feeling to realize that even our greatest achievements and discoveries make up only a fraction of what might exist. But is the cosmos truly infinite, or does it have a boundary somewhere? This question has occupied scientists, philosophers, and thinkers for millennia, leading to passionate debates and speculations. Some argue that the cosmos must necessarily be finite, as an infinite amount of matter and energy would be physically impossible. Others, in turn, believe that the infinity of the universe is a necessary consequence of our limited understanding of space and time. Ultimately, the answer to this question remains a puzzle that continually challenges us to question the limits of our knowledge, develop new theories, and seek insights that could revolutionize our understanding of the cosmos. Throughout this video, you will experience what it would mean to exist in an infinite cosmos, in a universe that knows no boundaries and extends infinitely in every direction. Every moment of your life would be a tiny spark in the timeless eternity of the universe, a fleeting instant in the endless flow of cosmic history. There would be countless possibilities and wonders to discover, worlds that surpass our boldest dreams and fantasies, civilizations and life forms so alien and mesmerizing that we can hardly imagine them in our limited imagination. But infinity also has a profound philosophical and existential dimension. In a boundless cosmos, there could be infinitely many copies of ourselves, infinitely many variations of our reality, unfolding in a dizzying kaleidoscope of possibilities. This idea can be both fascinating and unsettling, as it depends on notions of individuality, fate, and meaning. But could one even go beyond the boundaries of infinity? Is it conceivable to achieve the seemingly impossible and break through the barriers of the imaginable? These questions reflect our deep-rooted desire to explore the unknown, expand our minds, and transcend the limits of our understanding. Perhaps the answer to these questions lies beyond our current imagination, in dimensions and realities that we cannot even fathom, in concepts and ideas that shatter our familiar categories of space, time, and causality. Or perhaps infinity itself is the ultimate boundary that we can never cross, an eternal enigma that dooms us to keep bumping up against our own limits and yet never stop searching for new ways and possibilities. Today, dear viewers, we try to ask ourselves perhaps the weightiest question of all: is the cosmos infinite? Join us on a vast journey through space and time, and be excited to see what awaits you in this universe, whether with or without a boundary. Georg Cantor, the brilliant mathematician of the late 19th century, ventured into a terrain that had been considered untouchable for centuries, the exploration of infinity. With passion and dedication, he immersed himself in the abstract world of sets and numbers, driven by the burning desire to fathom the nature of infinity. This question literally drove him to madness, as he suffered a nervous breakdown in 1884 while exploring infinity. But before that, he kept returning undeterred to his desk to once again delve into mathematical problems. His enthusiasm and wit made him a valued conversationalist, even though his solitary struggle for mathematical insights was his true métier. But Cantor's ideas were far ahead of his time and met with incomprehension and rejection in the professional world. While Aristotle still considered the potentially infinite conceivable, a set that keeps growing through successive addition, the actually infinite, the infinite as a finished object, was considered unfathomable and even equated with God. Cantor, however, convinced of the freedom of mathematics, dared to break his taboo and put the infinite at the focus of his research. He classified infinite sets, compared them to the natural numbers, and made an astonishing discovery. Some infinite sets are more infinite than others. There are different levels of infinity. With ingenious tricks like the diagonal method, Cantor was able to show that the set of fractions is just as countably infinite as the natural numbers, even though there intuitively seem to be many more fractions. But with the real numbers, he encountered a higher level of infinity. They are no longer countable. There are more of them than natural numbers. Cantor's elegant proofs, often based on proofs by contradiction, were as revolutionary as the insight themselves. Even though calculating with infinite sets contradicts our gut feeling and is not intuitively comprehensible, Cantor's work laid the foundations for a completely new understanding of infinity. But the professional world was not yet ready for Cantor's groundbreaking ideas. Instead of earning recognition and fame, he faced hostility and rejection. Even the highly esteemed mathematician Carl Friedrich Gauss had strictly opposed the use of the completed infinite. Cantor's hope for a professorship at a prestigious university was shattered. Instead, he remained in provincial Halle throughout his life. But despite all the resistance and personal crisis, Cantor was not discouraged. With unshakable faith in the freedom of mathematics, he undauntedly explored the universe of infinities and created a work of epochal significance. But when we look at the cosmos, we are first and foremost confronted with finiteness. With the naked eye, we see a finite number of stars and planets. There are only a certain number of stars in the Milky Way, etc. But what if we extend that to the entire universe? Let's apply Cantor's question about the infinite to the observable universe. It stretches across a distance of about 93 billion light-years and encompasses everything we can see since the Big Bang about 3.8 billion years ago. This apparent contradiction, an age of 13.8 billion years, but an extent of 93 billion light-years, is explained by the expansion of space itself. While light has been moving through the universe at the infinite speed of light since the Big Bang, space itself has expanded, so that the distance between us and the most distant observable galaxies is much greater today than the distance light has traveled in 13.8 billion years. This expansion of the universe was first observed in 1929 by Edwin Hubble, who found that galaxies are moving away from us faster the farther away they are. This observation was the first indication of the expansion of the universe and ultimately one of the foundations for the theory of the Big Bang. Today, through precise measurements of the cosmic microwave background and afterglow of the early universe, we know that the universe was initially unimaginably hot and dense and has been steadily expanding and cooling since the Big Bang. But already when observing the matter of the cosmos, we run into a problem. A large part of it seems to be inaccessible to us. Specifically, we are talking about dark matter and dark energy, which together make up about 95% of the energy content of the whole universe and have not yet been directly observed. Their existence is inferred from their gravitational effects on visible matter, from gravitational lensing effects, and from deviations in the rotational velocity of galaxies. Without dark matter, the observed large-scale structure of the universe, with its colossal galaxy clusters and cosmic filaments, would not be explicable. And no, this is not simply a placebo for magic or something esoteric. Scientists have demonstrated the effects of dark matter many times, including in the rotation of galaxies, and have even used it as a gravitational lens. This counterpart to luminous matter, which is also called baryonic matter, by the way, exists. But in what form and how it interacts with the luminous stuff besides gravity is not yet known and represents one of the greatest mysteries, if not the greatest puzzle of cosmology. Dark energy, on the other hand, seems to be responsible for the accelerated expansion of the universe, which was discovered in the late 1990s through observations of distant supernovae. Deciphering the nature of these two enigmatic components is one of the main goals of modern astronomy and cosmology. Many experiments, such as the Large Hadron Collider at CERN, are searching for particles that could be candidates for dark matter, while precision measurements of the cosmic microwave background and large-scale surveys of the galaxy distribution are trying to constrain the properties of dark energy. How much the observable universe is characterized by finitude, we see in the so-called light archaeology or light paleontology. This is nothing other than the extremely unique aspect of light having traveled to us from far and carrying with it the knowledge of the past. Each particle of light, or wave, and every radiation in any spectrum allows us a glimpse into the past. Since light takes time to reach us, we see distant objects as they looked at the time the light was emitted from them. The light from the sun, for example, is about 8 minutes old when it reaches our eye, while the light from the nearest stars takes years, decades, and even hundreds of years to reach us. With the most powerful telescopes, we can observe galaxies as they appeared billions of years ago, not long after the Big Bang. The Hubble Space Telescope has even photographed galaxies whose light has been traveling to us for over 13 billion years. These images show us galaxies in their youth, when they had just begun to form stars. By studying such distant objects and structures in the universe, and understand the physical processes that shaped the early universe. In this sense, the observable universe is a vast cosmic archive that carries within it the history of the cosmos. Finitude is once again needed when we deal with one of the most exciting discoveries of recent years: the first direct observation of gravitational waves by the LIGO Observatory in 2015. These waves are ripples in space-time itself that propagate at the speed of light and are generated by the most dramatic events in the universe, such as the collision of two black holes, two neutron stars, or one black hole and a neutron star. Albert Einstein had predicted their existence as early as 1916 in his general theory of relativity, but it was only a century later that technological capabilities had advanced to the point where these tiny distortions of space-time could actually be measured. Gravitational waves open up a whole new window to the universe, as they can provide information about events that are not observable with electromagnetic radiation. In combination with classical astronomical observations, they promise a more comprehensive picture of the observable universe and could help solve puzzles such as the nature of dark matter or decipher the physics in the extreme conditions inside black holes. Despite the enormous advances in the exploration of the observable universe, there are still many open questions and puzzles that challenge astronomers and cosmologists. One of them is the fate of the universe itself. Will the expansion continue forever, driven by the mysterious dark energy, so that the universe ends in a big freeze, where all stars have gone out and galaxies are so far apart that no new star formation is possible? Or is there a yet unknown mechanism that could one day stop the expansion and perhaps even reverse it, leading to a big crunch, a collapse of the universe into itself? These questions touch not only our scientific understanding, but also our philosophical and spiritual reflection on our place in the cosmos. We can perhaps imagine the observable universe if we consider it as a graphic and, so to speak, define clear boundaries. But is that really all there is? Or is there more than just the observable universe, just the observable part of the cosmos? Is there somewhere out there an infinite universe? One that has no boundaries and cannot be grasped? Come with me as we try to track down an undetectable cosmos. It doesn't seem very smart to hunt for an endless cosmos. How can we prove infinity when we don't receive the light from stars and galaxies beyond a certain horizon because it doesn't reach us at all due to the accelerated expansion of the cosmos? And can there really be so much matter that an infinite cosmos can be created from it? The question of infinity has occupied scientists and philosophers for centuries and has led to many exciting theories and speculations. As early as the 4th century BC, the Greek scholar Archytas of Tarentum considered what would happen if one traveled to the edge of the sky and then extended one's hand beyond it. Since, in his opinion, there could be nothing greater than the sky itself, this implied a boundless space, an essentially infinite universe. This idea was taken up and developed further throughout history. In the 16th century, the Italian philosopher Giordano Bruno also came to the conclusion that space was infinite and contained infinitely many things, a statement that deeply angered the Church and ultimately led to his imprisonment, torture, and burning at the stake. Never before had the contemplation of infinity been so life-threatening, and Bruno's fate shows how controversial and explosive this topic was in the past. In the following century, the English philosopher Thomas Hobbes came to a much more acceptable and less dangerous conclusion about the nature of the infinite universe. He argued that it was pointless to speculate about whether there is an infinite cosmos beyond what we can see or not, because there is simply nothing we can do to measure or explore it. Better to file away the idea and instead deal with the many mysteries we can actually see and investigate, rather than those we will never see. Whether out of self-preservation or genuine conviction, his claims echo through the centuries and are still repeated today by many scientists who warn of the dangers and frustrations of speculating about the unobservable. So, why get entangled in pointless thought games when nothing tangible or useful comes of it? Today, however, we have better tools and methods at hand than ever to explore the observable universe and probe its boundaries. We can draw on centuries of science, mathematics, and philosophy that help us fathom and understand the possibly infinite reality of what lies beyond our horizon. Yet our view of the cosmos is also limited by the breadth of our gaze and the reach of our instruments. Electromagnetic waves in the form of light, radio, and other spectral ranges are our primary means of exploring the universe. They never move faster than about 300,000 kilometers per second, and the further we look into space, the further we look back into the past. We already know that. We can see galaxies from 1 billion years ago, from 5 billion years ago, even from 10 billion years ago, snapshots from long-gone epochs. But at distances equivalent to about 13.4 billion years, the light fades away and we reach a fundamental limit. The edge of our observable universe is thus defined as much by time as by space. It marks the point to which light has been able to penetrate to us since the Big Bang. We know that already. It is not a physical obstacle or a tangible barrier, but a measure of the finite speed of light and the expansion of space. The actual distance to this edge is determined not only by the age of the universe, but also by the continuous expansion that has taken place since these first galaxies began to shine. Their light has been traveling for 13.8 billion years. So they must be at least 13.8 billion light years away. But since space has continually expanded, in the meantime, these earliest galaxies are actually about 46 billion light years away from us today. The observable universe is thus much larger than one might guess at first glance, and its true dimensions far exceed our everyday experience. But as enormous as these numbers may be, when we examine the boundaries of our observable universe, it becomes very clear that they do not at all look like real physical boundaries or edges. There is nothing in the structure, distribution, or motion of distant galaxies to suggest that they are piling up against an invisible wall or barrier, or that their speed is being stopped. On the contrary, although from a theoretical perspective, it is extremely unlikely that the cosmos began with a perfectly uniform distribution of matter and energy. That is precisely the picture that presents itself to us on the largest scale. No matter which direction we look, space seems to be expanding more or less uniformly and isotropically. There is no preferred center or distinguished orientation. On scales larger than about 230 million light-years, we found no significant differences in the density, temperature, or structure of cosmic matter, but an amazingly homogeneous and symmetrical universe. This large-scale uniformity, confirmed by precise measurements of the cosmic microwave background, is considered strong evidence for the theory of cosmic inflation, an extreme expansion phase in the first fractions of a second after the Big Bang, during which the universe expanded by many orders of magnitude, effectively blowing away smaller irregularities and fluctuations. But even taking into account the smoothing effect of inflation, a universe with an observable diameter of only 92 to 96 billion light-years seems too small to completely erase the expected primordial inhomogeneities. In other words, if the universe is not infinitely large, it must be at least many orders of magnitude larger than the part we can directly see in order to be consistent with observations and theoretical predictions. As Thomas Hobbes rightly noted, however, there is no way to directly explore or measure these hidden regions beyond our horizon. We must instead rely on indirect evidence and theoretical arguments to fathom the true size and geometry of the cosmos. One such indirect clue might lie in the global topology of the universe. If the cosmos is very large but not infinite, it must have a certain geometric shape or structure. Some models predict that a finite universe would have a closed, spherical geometry in which parallel lines would eventually meet again, similar to the surface of a sphere. Other theories postulate a toroidal or donut-shaped universe in which traveling in a certain direction would eventually bring you back to your starting point. In either case, one could theoretically travel around the universe and end up back where one started. So far, however, neither observations nor simulations have found any signs of such global curvature or periodic structure. On the contrary, all measurements indicate that the cosmos is flat on the largest scale, a result most consistent with an infinitely extended universe. Another theoretical argument for an infinite universe arises from the concept of inflation itself. If the cosmos indeed expanded by many orders of magnitude in its early moments, as predicted by inflation theory, then it is very likely that this process did not end everywhere at the same time. Instead, inflation may have stopped earlier in some regions than in others, leading to bubbles or pockets in which separate universes with possible different physical laws and properties developed. Our observable universe would then be just one of countless such bubbles, embedded in a much larger multiverse or megaverse of potentially infinite extent. Although this idea is highly speculative and eludes direct empirical verification, it is considered by many cosmologists as a plausible consequence of inflation theory and could explain why the natural constants in our universe seem so finely tuned to enable the emergence of stars, planets, and ultimately life. Ultimately, however, the question of the infinity of the cosmos remains open and may never be answered with absolute certainty. As the Austrian physicist and Nobel laureate Erwin Schrödinger once remarked, "Infinity is a terrible, difficult concept. Everyone who has never thought about it has been confused by the paradoxes it seems to imply. Perhaps we will never know if there is more to discover beyond our cosmic horizon, or if we are indeed swimming in a boundless sea of space and time. But the search for answers to these profound questions will undoubtedly continue to occupy us for a long time to come and shape and expand our view of the world and our place in it. As astrophysicist Martin Rees aptly put it, the observable universe is vast, but it may be only a tiny corner of what is out there. And while we may never know what could exist in those distant realms, it is one of mankind's noblest endeavors to keep exploring and understanding." What would happen to us humans, what would happen to other intelligent civilizations, if we all lived together with the stars, planets, galaxies in an infinitely large space? Could we even still speak of space or a place if we have a universe before us that is gigantic beyond all measure? Would the word gigantic even be appropriate for it? First of all, we must note, the idea of living in an infinite universe would fundamentally revolutionize our understanding of space, time, matter and energy, and call into question many of our most fundamental assumptions about the nature of reality. In a truly boundless cosmos, there would potentially be infinitely many galaxies, stars, planets, and life forms stretching into the most remote reaches of space. An almost inconceivable number of worlds and possibilities that surpasses any imagination. Even if we make the conservative assumption that only a vanishingly small fraction of these planets have the necessary conditions for the origin and development of life, the chances for the existence of extraterrestrial civilizations would still be astronomically high. Given the sheer size and vastness of an infinite universe, it seems virtually inevitable that intelligent life has developed not just once, but countless times in the most diverse places in the cosmos. We humans may be just one of billions upon billions of species striving to find, comprehend, and fulfill their place in an infinite universe. Or, to put it simply, in an infinite space, there's infinite matter, thus infinitely many stars, and also infinitely many possibilities for the emergence of life. There would therefore be an endless number of possible alien civilizations, but they could be so far away from us that we would probably never be able to communicate with them. On the one hand, this realization could fill us with humility and relativize our supposedly unique and privileged position in the cosmos. On the other hand, it also holds enormous inspiring and comforting potential, because it implies that we are almost certainly not alone, and that there are almost certainly other sentient beings out there asking similar questions, facing similar challenges, and seeking similar answers as we are. But these beings might be hundreds of billions of light years away from us in a boundless cosmos, and thus unreachable for us. But what about the fundamental building blocks of reality? Matter, space, energy, and time. An infinite universe would also have far-reaching and downright disturbing consequences for our understanding of these anchors of reality. In a finite, bounded cosmos, there is necessarily only a finite amount of atoms, molecules, and subatomic particles that can combine and arrange themselves in a finite, albeit astronomically high, number of ways. In a truly infinite universe, however, the number of possible configurations of matter and energy would be literally unlimited. every conceivable arrangement of particles, atoms, and molecules, no matter how improbable or bizarre, would necessarily be realized somewhere in the cosmos. This means that somewhere in the immeasurable vastness of space, there could not only be planetary systems that are confusingly similar to our own solar system, but also worlds that resemble our Earth in every tiny detail, right down to exact copies of ourselves, our families, friends, and loved ones. These cosmic doppelgangers would not only be superficially similar, but identical to us atom for atom, equipped with all our memories, thoughts, hopes, dreams, and emotions. This seemingly absurd consequence necessarily follows from the laws of combinatorics and probability theory when applied to an infinite space. Even though the chances for the occurrence of such perfect copies are vanishingly small and hardly meaningfully quantifiable, the infinity of the cosmos implies that even the unimaginably improbable must become reality somewhere and sometime. This astonishing insight could shake our understanding of individuality, uniqueness, and free will to its very foundations and force us to radically rethink long-held notions of identity, destiny, and fate. And time would not have it too easy in a boundless cosmos either. In a finite universe with a defined starting and ending point, time seems to have a linear direction and a clear causal structure. It flows inexorably from the past through the present into the future, driven by the laws of thermodynamics and the increasing entropy of the cosmos. In an infinite universe without spatial and temporal boundaries, however, time could have a completely different topology and dynamics. Perhaps there are infinitely many parallel timelines or timestreams that branch out, intersect, and merge again like the ramifications of a cosmic river network, without ever reaching a final destination or ultimate resting state. Or time is truly cyclical and repetitive, so that the history of the cosmos repeats itself infinitely often in an eternal cycle, and every moment, every decision, every action is replayed and varied forever and ever. Some physicists and philosophers have even gone a step further and speculated that time in an infinite universe may not be a fundamental quantity at all, but only an emergent phenomenon or an illusion arising from the interaction of matter, energy, and gravitation. If the cosmos has no absolute beginning and no absolute end, the apparent direction and structure of time might in truth be only an artifact of our macroscopic perspective, just as the apparent motion of the sun across the sky is only an illusion caused by Earth's own rotation. These considerations are currently still highly speculative and elude unambiguous empirical verification. But they illustrate how radically an infinite universe could revolutionize and expand our understanding of time, causality, and determinism. In an endless universe, there would also be far-reaching practical consequences for the future of humanity and our efforts to find, secure, and expand our place in the cosmos. In a finite universe, vital resources such as matter, energy, living space, and raw materials are necessarily limited and finite, which inevitably leads to conflicts, competition, and existential risks as more and more actors compete for a shrinking pool of possibilities, like we see on Earth. In a truly infinite cosmos, however, there would in principle be enough space and resources for everyone. Every species, civilization, or society could spread, develop, and unfold unhindered without ever hitting ultimate limits to growth and expansion. This does not mean, of course, that the colonization and exploration of space would be an easy or risk-free endeavor. The distances, obstacles, and challenges between the stars and the galaxy would still be immense, perhaps even insurmountable given the fundamental constraints imposed on us by the laws of physics. But the mere theoretical possibility of an unlimited cosmic future could have a profound impact on our long-term goals, priorities, and perspectives, and motivate us to expand our horizons beyond the immediate needs and concerns of our home planet. Perhaps the true destiny of our species lies in rising to a Type 3 civilization on the Kardashev scale over the coming millennia and millions of years, a highly advanced culture capable of harnessing and controlling the resources and energy flows of entire galaxies. In an infinite universe, however, even that would only be the beginning. The first step of a never-ending odyssey that could take us to ever new cosmic shores over unimaginably spans of time and distance. Whether we will ever be able to reach inhabited exoplanets, make contact with alien civilizations, or even overcome the boundaries of our own universe is literally written in the stars. But the pursuit of it could give our existence a deeper meaning and purpose, the chance to contribute to something that points far beyond our earthly concerns and limitations, and gives our brief, fleeting stay in the cosmos a kind of cosmic significance. But even physicists are not only at a loss, but downright clueless in the face of the lack of evidence we are confronted with here. But sometimes it is the not knowing that we have to accept, because as the brilliant physicist and Nobel laureate Richard Feynman once remarked, "I can afford not to know." It is much more exciting to live in a world where we know and understand not everything, and where there is always something new to discover and explore. It is wonderful to have questions to which we do not yet know the answer. It is a privilege and an adventure to know that there are mysteries into which we have not yet been initiated. In this sense, the possible infinity of the cosmos may be the greatest lesson in humility, wonder, and intellectual modesty that the universe holds for us. An invitation to keep pushing the boundaries of our knowledge and embark on a journey with no foreseeable end. In a universe without borders, there will always be new horizons to discover, new puzzles to solve, and new wonders to marvel at. An inexhaustible source of admiration and inspiration for all future generations of researchers, explorers, and visionaries. Our exploration of the cosmos has only just begun, and no one can predict where it will take us and what surprises and revelations it holds in store for us. Perhaps one distant day we will realize that the science fiction vision of visionary author Arthur C. Clarke was more than just a bold dream. He said, "In infinity, countless wonders await to be discovered by us. It is the fate and destiny of our species to strive for these wonders, to keep pushing the boundaries of our knowledge, and perhaps one day even to cast off the shackles of our own universe. For only in infinity will we be able to unfold our true potential and find our ultimate destiny." A finite universe, an infinite cosmos, or somehow perhaps even both. Could there be anything greater and wilder than that? Could one venture even further than infinity suggests? In the infinite expanses of the cosmos, beyond the boundaries of our boldest imaginations and wildest dreams, a reality could exist that completely overshadows everything we have so far considered possible. Beyond the boundaries of our cosmos, other islands of reality could exist, which together can be called the multiverse, a hodgepodge of universes of unimaginable size and complexity, in which our own universe with all its billions of galaxies, stars and planets is just one of perhaps countless one existing side by side, separated by the gossamer thin, barely perceptible membranes of space-time. Imagine looking up at the twinkling night sky on a clear night, expecting to see the familiar constellations and points of light of our universe, but suddenly catching a fleeting, barely perceptible glimmer of something alien and inexplicable. Luminous spiral galaxies and bizarre star patterns that cannot be assigned to any known galaxy or star group shimmer for a brief moment at the edge of your field of vision before disappearing again into the infinity of the night. A barely palpable tingling runs over your skin, and as your mind tries to grasp the incomprehensible, could it be that you just caught a glimpse of the cosmic neighborhood, of a parallel universe that is so close and yet so infinitely distant? Scientists from all fields would deploy all available resources and state-of-the-art technologies to search for tangible evidence of the existence of these hidden worlds and to catch even a brief glimpse of this parallel reality. Using sensitive gravitational wave detectors capable of detecting even the tiniest tremors in the fabric of space-time, they would search for the subtle traces of interactions between universes, for the barely measurable distortions and vibrations that could arise when two cosmic neighbors brush against each other. They would analyze the cosmic microwave background, the faint echo of the Big Bang, with unprecedented precision, searching for tiny irregularities and deviations that could point to the massive collision of two universes in the early days of the cosmos. Any anomaly, no matter how small, any pattern, no matter how inconspicuous, could be the crucial key to unlocking the door to a new reality and forever changing our understanding of the cosmos. But what would it feel like to live in a multiverse where the boundaries between universes are as thin and permeable as the pages of an open book? Would we sense the presence of our cosmic neighbors like a constant, barely perceptible hum in the back of our minds, like an alien melody vibrating through the strings of space-time, reminding us that we are not alone? Perhaps there are places in our universe where the veils between worlds are particularly thin and translucent, a kind of spiritual nexus points and interdimensional ports that allow the knowing and courageous ones to catch a fleeting glimpse of the unimaginable wonders and horrors that lurk beyond our cosmic horizon. At these almost sacred sites, the laws of physics could warp in bizarre and inexplicable ways. Space and time could twist and intertwine like a Mobius strip, floating rocks, flowing stars, landscapes of liquid light and crystalline darkness. In the borderlands between universes, literally anything could be possible. And amidst this surreal kaleidoscope of possibilities and impossibilities, gates to the other worlds could open, shimmering energy portals waiting to be crossed by curious souls. But one can only guess at the consequences of such a crossing. Would brave explorers who venture through an interdimensional gateway ever be able to return? Or would they be trapped forever in an alien cosmos, cut off from everything they know and love? Would they be stranded in a reality where the fundamental constants of the universe are completely different, where there are no stars, where time flows backwards, and life exists in forms we can't even imagine in our wildest dreams? Or would they end up in a mirror universe, a twisted parody of our own world, where they encounter nightmarish versions of themselves, where all their decisions have been reversed? The risks of such an endeavor could be unbelievably high, and yet the thirst for knowledge in some pioneers could be so burning that they would be willing to risk everything to take a glimpse beyond the veil of reality. And who knows, they might find ways to make contact with the alien inhabitants of neighboring universes, to establish a dialogue that spans space and time. They might encounter civilizations whose technology and spirituality are eons ahead of our own, who have long since mastered the boundaries of physics and move freely between universes. But such contact would not be without risk, for who could say whether these higher beings are benevolent? or whether they see in us another primitive species to be subjugated, exploited, or even terminated. In a multiverse, the possibilities would be truly boundless. And so would the dangers and temptations be. Every decision we make, every thought we think, every action we take could create countless alternate realities, could steer our cosmic fate down ever new paths. Imagine being able to peer through the misty veils of probability and see all the lives you could have led if you had taken different turns at the crossroads of your life. In one universe, you may be a celebrated hero, a visionary leading humanity to the stars and forever changing the face of the galaxy. In another, you are a merciless monster, a tyrant who plunges entire civilizations into ruin and sets his universe ablaze. The sheer endlessness of possibilities would be both exhilarating and deeply disturbing, a constant reminder of how fragile and arbitrary our existence is, how easily everything could have turned out differently. If you knew that somewhere out there exists a version of you living out your darkest impulses, this knowledge could you drive insane or tempt you to follow suit, to throw all moral barriers overboard. That every decision you make, no matter how small and mundane, has been made somewhere by another version of yourself with consequences that could shake entire universes. This concept of quantum branching, the splitting of reality at every crossroads of probability, would completely upend our understanding of free will and destiny. Who could still believe in an ultimate, God-given destiny, knowing that out there are myriad branches and alternatives? Yet perhaps therein lies a deep spiritual truth that we are all on a journey to choose our unique path from the infinite variety of possibilities to forge our very own cosmic destiny. That each of our choices, no matter how small, creates a new world, and thus places upon us the responsibility to choose wisely and compassionately, knowing the far-reaching impact of our actions. And who knows, maybe our universe is just one of countless trial runs, a cosmic training ground where a higher power always play out all eventualities before deciding on the true course of history. A dizzying, almost heretical thought that all our striving and suffering, our joys and triumphs, may in the end have no ultimate meaning, that we are merely actors in an infinite repertoire of possibilities. Yet this very notion could also free us from the paralyzing pressure to always have to make the right decisions. It could give us the courage to follow our innermost hearts, to act fearlessly and with deepest compassion, knowing that no path can ever truly be wrong in a multiverse full of parallel worlds and alternate realities. Well, where is your mind stuck right now? In an alternate dimension, or rather universe? In the infinity of our unique cosmos, or in the glowing spiral arms of a galaxy far, far away? Wherever you are, I'd like to pick you up and bring you back to our actual world, where finitude represents our reality. During our incredible journey through the immeasurable vastness of the cosmos, we encountered an almost infinite variety of perspectives and insights that bring us closer to the answers to the fundamental questions of the infinity of the universe. From the humbling reflections on the almost unimaginable numbers of atoms in the universe, which according to recent estimates is said to be around 10 to the powers of 82, to the downright revolutionary discoveries of the brilliant mathematician Georg Cantor about the different levels of infinity, such as the countable infinity and natural numbers, and the uncountable infinity of real numbers, we have seen how the idea of a truly boundless cosmos continually challenges our minds anew and inspires ever bolder flights of fancy. The almost unbelievable advances in the exploration of the observable universe, from the groundbreaking discovery of cosmic microwave background radiation by Arno Penzias and Robert Wilson in 1965, which confirmed the Big Bang, and the origin of the cosmos about 13.8 billion years ago to the first direct observation of gravitational waves by the LIGO Observatory in 2015, which brilliantly confirmed Einstein's predictions from the general theory of relativity, have provided us with an increasingly detailed and precise picture of the cosmos, even though many fundamental puzzles such as the enigmatic nature, which makes up about 90% of all matter in the universe, and the even more mysterious dark energy, which seems to be responsible for the accelerated expansion of the cosmos, still remain unsolved and reveal the limits of our understanding. And finally, we have seen how great thinkers from antiquity to the present have repeatedly grappled with the equally exceptional and disturbing idea of an infinite universe, from Archimedes' ingenious method of calculating the volume of a sphere and Archytas of Tarentum's famous thought experiment about a spear thrown to the edge of the universe, to Blaise Pascal's shattering vision of an infinite silence of the cosmic spaces, and Thomas Hobbes' urgent warning about the dangers of speculating about the ultimately unobservable. But as impressive and inspiring as all of these findings and discoveries may be, the ultimate questions of the actual infinity of the cosmos seems to be one that still eludes a definitive answer, at least on the basis of our current knowledge and our current observational capabilities. Although we can measure the observable universe with ever greater precision, such as through the measurements of the Planck satellite, which determined the diameter of the observable universe to be about 92 to 96 billion light years, and formulate ever more sophisticated theories about its origin and evolution, such as the theory of cosmic inflation, which explains the formation of large-scale structures in the universe through a phase of exponential expansion in the first fraction of a second after the Big Bang. But the questions of what lies beyond our cosmic horizons remain open and elude direct empirical verification. Even if we were one day able to map and understand the entire observable universe down to its last corners, and perhaps even find evidence for the existence of other universes within the framework of a multiverse theory, as predicted by some models of string theory, for example, there could still be an infinitely larger cosmos that will forever elude our direct perception and our limited understanding. In this sense, infinity is perhaps less an objective physical property of the universe itself than a fundamental limit of our human understanding, a constant reminder that there will always be something that is unimaginably much larger than what we can grasp and comprehend with our limited minds. But even if we may never be able to answer the fundamental questions of the actual infinity of the cosmos with ultimate certainty, the intensive engagement with this question and all its unbelievable implications has an almost immeasurable value for our human thinking and our creative imagination. By constantly confronting the limits of the conceivable and trying with all our might to grasp the seemingly impossible and put the incomprehensible into words and thoughts, we constantly expand our mental horizon and push forward to ever new, often completely unexpected insights and understandings. The long and extremely varied history of cosmology and mathematics is full of impressive examples of how the relentless struggle with the infinite and its manifold aspects has led to groundbreaking discoveries and revolutionary theories, from Einstein's general theory of relativity, which fundamentally redefined our notions of space, time and gravity and opened up astonishing new insights into the curved spacetime of the universe, to the highly complex and still hotly debated models of quantum gravity such as loop quantum gravity or M-theory, which attempt to unify the seemingly incompatible physics of the infinitely small at the level of quantum phenomena with the physics of the infinitely large at the level of cosmological structures and processes in a theory of everything, and in doing so arrive at truly breathtaking speculations about the nature of space, time and matter, to the most recent reflections on so-called multiverses, parallel universes or baby universes that constantly emerge from quantum mechanical fluctuations and could form a kind of cosmic foam. In this sense, the question of infinity is perhaps less a question about the objective reality of the cosmos than an inexhaustible driving force for our ongoing pursuit of knowledge and understanding, which repeatedly spurs us on the new heights of the mind and leads our thinking into unimagined expanses. Ultimately, we may be left only with the reverential certainty that we live and act as transient sparks of consciousness in a cosmos whose true nature and dimensions transcend everything we can imagine or express. And that the greatest wonder and the deepest mystery is not hidden somewhere out there in the farthest depth of our universe, but within ourselves. In our very own ability to conceive the inconceivable and strive for the infinite. Whatever the true nature of the universe may be, whether finite or infinite, as long as there are beings like us who do not stop asking about it and searching for an answer with all the powers of mind and imagination, it will remain a source of inexhaustible amazement and an object of never-ending fascination. Therein perhaps lies the deepest consolation and the highest destiny that we can find for ourselves in the face of the overwhelming infinity of the cosmos, that it is we ourselves who give meaning to the universe by ceaselessly striving to decipher its mysteries and comprehend its beauty. And that this never-ending search for knowledge and understanding constitutes our very essence and gives our fleeting presence on this world a significance that reaches far beyond our earthly existence.